Hi everyone, the channel Easy Lecture welcomes you. So in this video again we are going to discuss the next 50 formulae. We have completed up to 250th formulae in the previous part. In this part we will be discussing formulae from 251 to 300. So we shall start straightly. So we are discussing the root mean square of different waveforms. So in 251, formula number 251, for a sawtooth signal, Vrms is equal to Vm by root 3. For a triangular waveform, Vrms is equal to Vm by root 3. So for these two things, the root mean square value is same. Okay, now average value, average voltage. Okay, for a sinusoidal signal, for a sine waveform, V average is equal to 2 Vm divided by pi. For a full wave rectified signal, V average is equal to 2 Vm by pi. For a half wave rectified signal, V average is equal to Vm by pi. For a square waveform, V average is equal to Vm. For a square waveform which has amplitude only in positive direction, V average is equal to Vm by 2. For a sawtooth waveform, V average is equal to Vm by 2. For a triangular waveform, V average is equal to Vm by 2. Form factor equal to V RMS divided by V average. Peak factor equal to Vm divided by V RMS. For square wave, peak factor is equal to 1, form factor is equal to 1. V RMS is equal to Vm by root 2, that is equal to 0.707 Vm, that is equal to 70.7% of maximum amplitude of voltage signal. V average is equal to 2 Vm by pi, that is equal to 0.637 into Vm, that is equal to 63.7% of maximum amplitude of voltage. So here from number 265, peak amplitude of voltage is greater than root mean square amplitude of voltage, which is also greater than average value of amplitude of voltage. Formula number 266, Vt equal to Vm into sin omega t. Similarly, current I of t equal to Im into sin omega t, and the power is equal to V into I, that is equal to Vm into Im divided by 2, that is equal to Vrms into Irms. 267, if frequency of current wave is f, then frequency of voltage wave is also f, then the frequency of power wave is equal to 2f. Okay, no, double times of the frequency of either current wave or voltage wave. When capacitor used in AC, voltage lag current by 90 degree. Okay, so when capacitor is used in capacitor, voltage lag current by 90 degree. V of t is equal to Vm into sin omega t. I is equal to C into dV by dt, that is equal to C into d by dt of Vm sin omega t. I of t equal to Vm divided by 1 by C omega into cos omega t. I of t equal to Vm divided by xc into cos omega t. So 1 by C omega is written as xc. xc is equal to 1 by omega c. Formula number 269, I of t is equal to Im into cos omega t, or Im equal to Vm divided by xc. Now inductor used in AC. When inductor used in AC, current lag voltage by 90 degree. I of t equal to Im sin omega t. So voltage is equal to L into di divided by dt, that is equal to L into d by dt of Im sin omega t, that is equal to omega into L into Im cos omega t. Formula number 272, V equal to Vm cos omega t, where Vm is equal to XL into Im, XL is equal to omega into L. For series RL circuit means the resistor and inductor are connected in series, and here we have a source which is denoted as Vt equal to Vm sin omega t. So for this kind of circuit, voltage triangle is given like this. So this is VR, this is load voltage, and by Pythagoras theorem we can write V equal to root of VR square plus VL square. So voltage across resistor. Okay, so VL, the voltage across inductor is given by I into XL. Similarly, the voltage across resistor is given by I into R by Ohm's law. And here this gives the phase pi, and V equal to I into Z. Okay, the current voltage is equal to current into impedance, and we have got V equal to root of VR square plus VL square. This is by Pythagoras theorem. Next, formula number 274, impedance triangle. So this is impedance triangle. Here we have the inductance, here we have the resistance, and here we have the total impedance, and the angle is again pi. According to Pythagoras theorem, Z is equal to root of R square plus XL square. Okay, now formula number 275, power triangle. So power triangle, this is power and QL and this is apparent power. So QL is reactive power, and this is power, this is apparent power, and S is equal to root of P square plus QL square by Pythagoras theorem. So QL is reactive power, S is apparent power, voltage, volt ampere. Power is P is active power or real power or effective power or average power, and the unit is in watts. Apparent power, the unit of apparent power is voltage ampere, volt amps. Okay. Then formula number 275, cos pi is equal to R by Z. So for this one, cos pi is equal to R by Z. Okay, so cos pi means adjacent side by hypotenuse side. So using the trigonometric identity, we are writing this formula. Cos pi is equal to R by Z. Similarly, cos pi here is equal to, the adjacent side is P and hypotenuse is S, so P by S. And similarly, in this triangle, when the same condition is applied, cos pi is equal to VR divided by VL. Okay, so this is for series RL circuit. Okay, now we are going to discuss series RC circuit. Series RC circuit, we have a resistor and capacitor in series, and there is a voltage source for which the instantaneous voltage Vt equal to Vm into sin omega t. Okay, and here also we are resolving it in triangles, impedance triangle. So impedance triangle, it is opposite to the impedance triangle of RL circuit. Okay, so the directions are different, because in when inductor is used in AC, here current lag voltage by 90 degree, whereas when capacitor is used in AC, voltage lag current by 90 degree. So for these reasons, there is a change in the direction of current. Okay, here we have XC, here we have R, here we have Z. So Z is equal to root of R square plus XC square by applying Pythagoras theorem. Formula number 277, B is equal to root of VR square plus VC square, same by applying by using it in voltage triangle. And similarly, by using in power triangle 278, S is equal to root of P square plus QC square. So in all these triangles, I have not drawn all the triangles, but in all the triangles the directions are different. The directions are like this for RC circuit, and the directions are like this for RL circuit. Okay, so I have not drawn voltage triangle and power triangle here. Okay, now for RLC circuit, the resistor, inductor and capacitor, all the things are in series, and we have a voltage source in which the instantaneous voltage Vt equal to Vm into sin omega t as usual. And instead of a triangle, we have this kind of graph to find the relationship between the impedance, voltage and power of resistor RLC series circuit. Okay, so impedance Z is equal to root of R square plus difference between XL and XC the whole square. Voltage is V is equal to root of VR square plus the difference between VL and VC the whole square. And the power, apparent power S is equal to root of P square plus the difference between QL and QC the whole square. So this is for RLC series circuit. Okay, then formula number 282. Now we are going to talk about RL parallel. Resistor and inductor are in parallel connection. Here this is the circuit, resistor and inductor are connected in parallel, and we have a current source I. V by Z is equal to V by R plus V by XL. 1 by Z is equal to 1 by R, that is equal to G, and 1 by XL is equal to BL. 1 by Z is equal to Y, 1 by R equal to G, and 1 by XL is equal to BL. For current triangle, we have load current, this is resistor current, inductor current, resistor current, and here we have the current. By Pythagoras theorem, I is equal to root of IR square plus IL square. Admittance triangle, since RL is connected in parallel and current source is used, instead of impedance we are using the technical term admittance. And admittance Y is equal to root of G square plus BL square. So this is admittance triangle. This is power triangle, and from power triangle S is equal to root of P square plus QL square. When RC are connected in parallel, so look at the direction of RL parallel and RC series, the directions are same. So the same direction. Okay, but here RC circuit, series RC circuit, whereas here parallel RL circuit. Okay, RC parallel will, the triangles of RC parallel circuit will be similar to that of series RL circuit. Okay, so the same direction. Okay, now here in RC parallel, the resistor and capacitor, they are connected in parallel, and current is used as the source. Formula number 285, current triangle, we have I equal to root of IR square plus IC square. Admittance, Y is equal to root of R square plus BC square. Power triangle, S is equal to root of P square plus QC square. Then RLC parallel, resistor, inductor and capacitor are in parallel. Here current I is equal to root of IR square plus difference between IL and IC the whole square. Admittance, Y is equal to root of G square plus the difference between BL and BC the whole square. Then power S is equal to root of P square plus QL difference QC the whole square. Okay. Now resonance in series, R, L and C in series. So XL is equal to, in for a resonance circuit, XL equal to XC. XL means omega L, XC means 1 by omega C. So that is what we have got here. Omega L equal to 1 by omega C. That means omega is equal to 1 by root of LC. Omega is the angular frequency. Z is equal to R, cos pi is equal to 1. I max is equal to V divided by Z min. Okay, so this is for resonance circuit. And this is the point of resonance. This is the point of resonance, and this is the frequency. This is the resonant frequency FR. And when XC is greater than XL, it comes in, the graph comes in this region, and this is the region of capacitance, and it is a leading circuit. And when XL is greater than XC, here we have the graph indicates this region. So this is XL, this is XC, this is omega L, this is omega C. When XL is greater than XC, and here XL is greater than XC, whereas here XC is greater than XL. So this is XC, this is greater than XL. So at this point it becomes an inductive circuit, and it is also otherwise called as lagging circuit. Okay. Then quality Q is equal to omega L divided by R, that is equal to XL divided by R, that is equal to VL divided by VR, that is equal to VL divided by V, that is equal to 1 by omega into RC. Then quality factor Q is equal to omega R divided by bandwidth. Omega R means resonant frequency, that is equal to FR divided by bandwidth. Formula number 300, omega naught equal to root of omega 1 into omega 2, which implies F naught equal to root of F1 into F2. So with this, 300th formula is getting over, and we are winding up today's video with this. Not today's video, again I will be posting the next 50 formulae in the next video today itself. So with this 300th formula, this part is getting over, this part of EC formula is getting over. Meet you again in another video. Until then, bye, stay in touch. Thank you. Don't forget to subscribe my channel EC Lecture. Thank you.